Good afternoon. So it's 12:05. We will wait for a minute for others to join. Six students right now. Before starting, in the last lecture we have discussed the kernel was given to us kx comma xi, that was e raised to power x cos xi. So in this case a was 0 and b was equal to pi. We have to calculate the resolvent kernel in this particular case. So in this case our resolvent kernel is gamma x comma xi semicolon lambda, that is equal to summation n equal to 1 to infinity. Then we have e raised to power x cos xi minus 1 raised to power n lambda raised to power n minus 1 1 plus e raised to power pi divided by 2 raised to power n minus 1. And if mod of lambda is less than 2 upon 1 plus e raised to power pi, in this case we will get resolvent kernel value, that is equal to 2 times e raised to power x cos xi divided by 2 plus lambda into 1 plus e raised to power pi. So this is the answer of resolvent kernel for this particular kernel. Second case I have given to you, that was sin x plus xi. In this case also a is equal to 0 and b is equal to pi. In this particular case we are getting our answer of the resolvent kernel gamma x comma xi semicolon lambda, that is equal to 1 upon 1 minus lambda pi divided by 2 square, then sin of x plus xi plus lambda pi divided by 2 cos of x minus xi. And in this case modulus of lambda is less than 2 upon pi. So this is the answer of resolvent kernel in this case. We have discussed these two cases. I have given these two questions to you to solve, and I have also written the answer of these questions. So right now we are going to start our today's lecture, and there is a question: find out the iterated kernel. We have to calculate K2. Find out the iterated kernel K2 x comma xi when the kernel x comma xi is given to us and its value is x and xi. Value of x when x is less than equal to xi and greater than equal to 0, and if x is less than equal to 1 and greater than equal to xi, in this case we have the kernel value as xi. We have to calculate K2 in this particular case. So we are already aware that K1 x comma xi, that is equal to K of x comma xi. Now we will try to find out the second iterated kernel. So our next step is to calculate k2x comma xi. So in this calculation, we have two cases with us. Just update me, what is the value of k2? k2x comma xi. According to the formula, as we are discussing the Fredholm integral equation, so the second iterated kernel is equal to the integration from, you can see lower is 0 and upper is 1. So integration will be from 0 to 1. Then at this position k, again k, k1, because we are going to calculate k2. So first variable is x, that will be here. Second variable is I, that will be here in this case. And we can use the variable t. So this is the formula. This is the formula. Now we have to calculate k2. But as you can see that the value of the kernel, we have two values. First value is x and second is xi. When x is less than equal to xi and greater than equal to 0, in this case our kernel is x. And when x is less than equal to 1 and greater than xi, in this scenario, we have the kernel value as xi. So right now we have two cases. The first case we are going to discuss, that is case number first. So if we take x greater than equal to xi, this is our first case. If the value of x is greater than equal to xi. In the second case, we will have x less than equal to xi. This will be our second case. We will discuss this case later on. So x may be less than equal to xi or x may be greater than equal to xi. So in the first case, as x is less than equal to xi, so we can write it as, so value we can write as equal to, you can see x is greater than equal to xi. So we can write this step as xi less than equal to x. And lower value is 0 and upper value is 1. So we have this value greater than equal to 0 and less than equal to 1. So in this scenario, we are going to calculate the value of the second iterated kernel. So in this particular scenario, what is the kernel? As x is greater than equal to xi. So in this scenario, the value of the kernel is xi. So we will use this kernel in this scenario. So when is x is greater than equal to xi, so when we will calculate the value of k2, as the limit of integration are from 0 to 1, so we will break this integration as integration from 0 to, you can say 0 to xi, because in this scenario our condition was xi less than equal to x, less than equal to 1 and greater than equal to 0. So we will break our integration from 0 to xi. Then we will have the kernel, then k1 t comma xi dt, and at this place we will have xt. Now the second integration will be from xi to x. Then at this position k of x comma t, k1 t comma xi dt. Now our third integration will be from x to 1. k of x comma t, and then we will have k1 t comma xi dt. Up to this step, any doubt up to this particular step? Value of the k2, we have break up this part into 3 integers. If you have any doubt, then update me. Otherwise, I will move further. Any doubt in this particular scenario? We were discussing the case xi less than equal to x less than equal to 1 and greater than equal to 0. You have to remember this particular scenario. So as far as this first integration is concerned, so we will have integration from 0 to xi. As the limit of integration is with respect to t, so we can say that t is greater than equal to 0, and then we will have, as the limit is from xi, so we can take as t is ranging from 0 to xi, and xi is less than equal to x less than equal to 1. So in the first integration, we are discussing this particular case. So the value of this kernel k of x comma t in this scenario, as k of x comma t, you can see here the kernel is k of x comma t. So our value is this xi, but the variable here is t. So we will use t, because the value of k of x comma xi is xi, because this particular scenario. So as x comma xi is xi, so x comma t will be t. So we have used t here. Now we have k1 t comma xi. So again, this is the case k1 t comma xi. So at this place we will use the value t, because k1 t comma xi, we have this value k1 t comma xi. So at this place we will again have value t, then dt. Now comes to the second part. In this second scenario, you can see that how, first of all, we will clarify this particular case k1 t comma xi. k1 t comma xi, we are already aware that is equal to kt comma xi. So in this case, you can see that k of x comma xi, as t is less than equal to xi, so in place of x we have t. So you can see that x, at this place we have t. So if in the place of x we have t, so we are going to calculate t comma xi. So in the case x comma xi, we have the answer x. If the value is t comma xi, then we will have t. So we have used t. So we have t comma t, t and t, then dt. This is the first integration, and we can easily solve this particular integration. Now the second integration, in the second case we have the limit from x to 1. Now in the second case, as you can see, t is greater than equal to x and less than equal to 1 in this case, because the integration is okay, we are going to calculate this particular limit. So in this scenario we have t less than equal to x and greater than equal to xi. You can see that again xi is less than x in this second integration, as the limit of t are from xi to x. So we can say that t is greater than equal to xi and less than equal to x. So we are discussing this particular case in the second integral. So the value of this particular kernel k of x comma t. So in this case we have the value of k of x comma t. So you can see that xi is less than x. So this is the case, and in this scenario we have the value of k of x comma xi is xi. So the value of k of x comma t will be t. The value of k x comma xi will be xi. So the value of k x comma t will be t. Now the value of k1 t comma xi, the value of k1 t comma xi, that will be k t comma xi, t comma xi, and we are discussing this particular case, this particular, because you can see in the second integral t is less than equal to x but greater than equal to xi. So xi is less than x. So if xi is less than x, then the value of k of x comma xi will be xi. So you can see that t comma xi. So if we have the value of x comma xi is xi, so t comma xi will be xi. So we have this value as xi. Then dt. In the third integral, you can see this is the third integral. This is the third integral. In this scenario, the value of t is greater than equal to x and less than equal to 1. And we have already discussed, we have taken the case when x is greater than equal to xi. We are going to discuss this case. So we will have x is greater than equal to xi. So in this particular third integral, we are discussing this case. So the third integral, that is from x to 1. So the value of the first kernel k of x comma t, you can see that the limit of integration are t. Limit of integration are with respect to t. So as x is greater than equal to xi, x is greater than equal to xi, this is the case in the third integral. So this is the scenario, x is greater than xi. So the value of x comma xi will be xi. So what is the value of x comma t? That will be t. In the third case, third integral, what is the value of k x comma t? As the limit of integration are with respect to t, as the limit of integration are with respect to t. So you can see that in third case, k of x comma t we have to find out, and here k of x comma xi is with us. K of x comma xi is x and xi. So in place of xi we have used t. So in place of xi, if we have t, so at this place we will have t, and at this place we will have t in the third integral. So you can see that x is less than equal to t. So you can see that x is less than equal to t. So this is the case. So our value will be x. So at this place we will have x. Now the value of k1 t comma xi. Now we are going to find out the value of k1 t comma xi. So this value will be, so in place of x we have t. In place of x we have t. So in place of x if we have t, so t greater than equal to xi. T greater than equal to xi. So in this scenario the value of k1 will be xi. So at this position we will have xi and then integration with respect to t. मैंने आपको हर एक इंटीग्रेशन, तीनों इंटीग्रेशन बिल्कुल ओपन करके बड़े इजी तरीके से हमने तीनों इंटीग्रेशन डिस्कस की हैं. नाउ वी कैन फाइंड आउट द सॉल्यूशन बाय सॉल्विंग दीज थ्री इंटीग्रेशन. सो वी विल हैव 0 to xi t square dt plus integration x to 1. Xi is common, xi is outside. So t dt, then we will have x and xi both are constant, x to 1 dt. So we will solve these three integration. In the first case we are getting t cube by 3. Overall answer will be xi cube by 3. The first integration is xi cube by 3. In the second case, as xi is common, so we have xi common and t dt will be t square by 2. So t square by 2, so we can take 2 outside and inside the limit are from x to 1. So we will have overall answer as 1 minus x square. In this case and this case we will have x and xi. Sorry for the calculation. The first integration is quite clear. So we have calculated this particular integration. In this case we have xi common, and this integration we will get t square by 2 limit from x to 1. In the third case we have xi common outside. Third integration we have got t, that is from x to 1. Now we can solve it. We are getting xi cube by 3 plus xi into 1 by 2 is outside. So we will have 1 minus x square plus xi. Third case we are getting 1 minus x. There is little bit confusion in the case of limit. I am again writing the integration. We have 0 to xi t square dt, then xi to x t into xi dt plus x to 1. We have at this position x xi dt. We have to solve these three integration. So in this case we are getting t cube by 3, limit is from 0 to xi, plus second case xi is common, we are getting t square by 2, limit is from xi to x. So plus in this case both are constant, so xi is common, integration dt, that is from x to 1. So in this case we are getting t from x to 1. we have to solve this particular integration. Now, in this case, we are getting our answer as, first case we are getting xi cube by 3 plus, you can see xi by 2, then inside upper limit, that is x square, minus lower limit, that is xi square, plus x xi into 1 minus x. This will be our answer of K2 in the case when x is greater than equal to xi. So in this case, we have calculated the value of K2. We have calculated the value of K2 in the case when x is greater than equal to xi. Now, if x is less than equal to xi, we have to calculate the value of K2. Just came back that kernel was given to us, that was x and xi. And you can see here x is less than equal to xi, greater than equal to 0. And in this case, xi is less than equal to x, less than equal to 1. So in this case, xi was less than equal to x, and in this case, x was less than equal to xi. So we can see that this case is symmetric case. The values of x and xi are just interchanged. So if we are going to discuss the second case, and we have calculated the value of K2 in the first case, so in this scenario, we have to just interchange the value of x and xi. So in this scenario, we will have the kernel as x cube by 3 plus x by 2 into xi square minus x square plus xi x. So again, we will have xi. Now at this position, 1 minus xi. So this will be the kernel in this scenario, and this is the kernel in this scenario. So you have to calculate the kernel with utmost care. Okay. Now there is another case. You have to calculate the resolvent kernel. Solve the following Fred-Helm integral equation of the second kind by calculating the resolvent kernel. The question given to us is ux equal to fx plus lambda integration from 0 to 1 x e raised to power xi, then we have u xi d xi. This is the Fred-Helm integral equation of second kind. So we will take it as equation number first. So in this case, what is the kernel? The kernel k of x comma xi is given as x e raised to power xi. So for the calculation of resolvent kernel, first of all, we have to calculate the iterated kernel. So the value of k1 x comma xi, that will be x e raised to power xi, because that is equal to kernel k. Now for the calculation of k2 x comma xi, the formula is from 0 to 1. Then we have two kernels here at this position k1, because we are going to calculate k2. So x comma and comma xi. So we will take the variable t here and integration with respect to t. We can easily calculate its value. So in the case of k3, we will have 0 to 1 k x comma t, k2 t comma xi dt. So we will calculate k1, k2, k3, k4, so on up to kn. k1, k2, k3, so on up to kn. So in this case, all the kernels are same. We have got k1 as x e raised to power xi. When we will try to solve this, we will again get x e raised to power xi. when we will calculate K3, we will have again x e raised to power xi. Similar way, we will have Kn as x e raised to power xi. All the values of the kernels are same. So now, according to the formula of the resolvent kernel, the formula for the resolvent kernel, gamma x comma xi semicolon lambda, that is given by K1 x comma xi plus lambda K2 x comma xi plus lambda square K3 x comma xi plus lambda cube K4 x comma xi, so on up to lambda raised to power n minus 1 Kn x comma xi, so on up to infinity. So when we will put the value of K1, K2, K3, all the values are same. So we will have x e raised to power xi common. Inside we will have 1 plus lambda square plus lambda cube, so on up to infinity. So you can see that this is infinite GP. If this is infinite GP, so in this case, this series will be convergent only if modulus of lambda will be less than 1. इनफाइनाइट जीपी में अगर आपकी रेशियो 1 से छोटी है तो आपका क्या फार्मूला होता है इनफाइनाइट जीपी के सम का a अपॉन 1 माइनस आर. तो क्या आंसर आएगा आपका इस केस में x e रेस टू पावर xi, और इसका क्या आंसर होगा a आपका 1 है, यहाँ पे रेशियो आपकी लैम्डा है. सो वी हैव द आंसर x e रेस टू पावर xi डिवाइडेड बाय 1 माइनस लैम्डा. ओके, अब हमने क्या कैलकुलेट कर लिया, वी हैव कैलकुलेट द रिजॉल्वेंट कर्नल. तो आपका जो सॉल्यूशन होगा, सॉल्यूशन इज गिवन बाय ux इक्वल टू fx प्लस इंटीग्रेशन 0 to 1 द रिजॉल्वेंट कर्नल, और रिजॉल्वेंट कर्नल के साथ आपके पास क्या आएगा f xi d xi, और आपका रिजॉल्वेंट कर्नल क्या है x xi सेमीकोलन लैम्डा. तो यहाँ पे आपको वैल्यू रखनी है जो हमने रिजॉल्वेंट कर्नल को कैलकुलेट किया है. Okay, so today we have discussed 2-3 questions based upon iterated kernel and resolvent kernel. I will forward some PDF, some questions to you in the PDF format. That will be your assignment, and you have to solve that assignment related to unit second. You have to solve those questions and have to forward to me. Today is Tuesday. You have to forward your questions, answers of the questions to me before Tuesday next week. आपको अगले मंगलवार से पहले मेरे पास सॉल्यूशंस फॉरवर्ड करने हैं. माय ईमेल आईडी इज ऑलरेडी विद यू, तो उसी ईमेल आईडी पे आपको वो क्वेश्चंस फॉरवर्ड करने हैं एज असाइनमेंट. ओके, सो टुडे आई एम गोइंग टू कंक्लूड माय लेक्चर. All are requested right now to mention your roll numbers for the attendance. There is no need to mention your roll number earlier. When I asked you to do so, at that time you have to mention your roll number. I will consider only the attendance after 12:39. You all are requested to mention your roll number for attendance. ठीक है बच्चों, थैंक यू फॉर द क्लास. और इससे आगे जो टॉपिक होगा वी विल डिस्कस दैट इन आवर नेक्स्ट क्लास. अभी भी कोई अगर स्टूडेंट रह रहा है तो मेंशन योर रोल नंबर. So thank you for the class.